flip-flopping some of the
So
some
wouldn't
of the
that be
ones.
1/2 too?
Yeah, actually it is.
Yeah, I was like, isn't this the same problem?
Yeah, it is. I mean, maybe they're trying to show you that it's the same, so it ends up being 1/2 here. All right, so the next thing here is this. All right, so again, kind of the same thing here. It's probability of A, which we don't know, times 3/4 equals 27 over 80. Probably better to multiply by the reciprocal. All right, and so probability of A equals see here. So it's better to pre-reduce, like 27 goes into 3 9 times, 4 goes into 80 20, so 9 over 20.
Right. And then for the next one, oh no, it's not the same.
Why don't you try number 72?
Oh, it actually would be the same thing. It's 9 over 20.
Oh, it's like they ran out of numbers to use, so. All right. The next grouping of questions are for dependent probability. They don't say that, but there's two types of probabilities. There's independent and dependent. So the probability of dependent, the probability of A given B equals the probability of, let me do it this way, B over the probability of A and B, like that. So they always, the thing is, they're always going to give you 2 of the 3 values. So in this case, they're giving you the 4/5 equals the unknown over 3/5. It gets really awkward with fractions, I suppose. So, maybe here it's better to actually multiply by 3/5.
Yeah.
That's the only, or you could convert to decimals, like probably you're allowed. Probably, that may be an easier, illustration of this, because it'd be point on the bottom here. It's 0.6. Maybe it's easier to multiply by 0.6, 0.8 on the left. You get the same result, thankfully. So it's not too bad. So do you have a final answer for me on this one, either a fraction or a decimal?
So wait, I'm a little confused.
Well, I'm just trying to give you options here. You're just multiplying both sides by 0.6. If you prefer to use decimal, or you multiply both sides by 3/5.
Oh, okay. So then the answer would be 0.48 or
It's 0.48, or if you had a fraction, you can do it as a fraction.
yeah, or 12 over 25.
Right, exactly. So the like I said, there's 2 formulas here. There's the one for dependent, which you got to have down. And one thing that could be like the order of the letters does matter. The fact that A is first and then B does matter. And then the independent is the probability of A and B is the probability of A times the probability of B.
Okay.
And you really have to, sometimes they don't tell you, like in this case, in 73, 74, 75, 76, they don't tell you, but the other thing you have is like kind of can use the formula to say, okay, how can I rearrange this to work here? So let's take a look together at 74 here. Using that formula. So again, good to kind of write it out. We're trying to find the probability of A given B. That's the probability of B over the probability of A and B. They're always going to give you two of the three here. So in this case, B is, and maybe it's better just go right to a calculator or just say, okay, I'm going to convert that to 0.3. For the A and B, it's a little tougher, but you can probably figure out that it's 0.135. That's not right. I gave you, hang on a second. I gave you some bad information here. Let me, I believe I messed this up. I apologize. These are in the wrong place, and that's very bad. You can see how often I do this, which is not very often.
Yeah.
Okay. Whew. So that does actually change the previous problem here, and we'll come back to that. Let me just get this right here. So because I was looking at the numbers like, oh, that's not going to work. Probabilities have to be between 0 and 1, which is why I was sort of saying, oh, that's not going to work. This is 0.135. So it ends up looking like this. All right. And that ends up being 0.45. So I do have to, again, you have to kind of get this formula down. This is correct. The and goes on the top, the individual goes on the bottom. And we should redo the previous problem now because it's not correct the way I had presented it to you.
Okay, so it would
Let's,
just be,
yeah, so let me redo it here. So the probability of A given B equals the probability of A and B over the probability of B. So this time they're giving you on the left there 4/5 equals A and B, which is 3/5 over probability of B. And we were having this discussion like, okay, well, maybe it's better to just work with the decimals. I think it is like that. But how do we, this is one of those harder problems, like how do you get the variable out of the bottom? Okay, and to do that, you either multiply both sides by the variable or you flip. I don't know if either of those sound familiar to you. Cross multiply.
yeah.
Any of which sounds best to you?
Just cross multiply.
Okay, so it's 0.8 times the probability of B equals 1 times 0.6. Divide both sides by 0.8. Probability of B equals 0.6 divided by 0.8, which is 0.75.
Okay.
Okay, so let's do the next one here. 75. Really helps to have the correct formula, of course. So probability of A given B, that vertical line means given, is the probability of A and B over the probability of B. So A given B is 11 over 40, which you can convert to a decimal if you want. A and B is 33 over 200 over X. So again, we kind of have to get this variable out. It's probably good to cross multiply here. Now, do you see this as 11 over 40 over 1, or do you just want to leave it as 11 over 40?
Just 11 over 40.
Okay. So that means it's 11 times x equals 40 times 33 over 200. And believe it or not, this does work out kind of nice. You end up multiplying by 1 over 11. And you're going to see a bunch of cancellations here. So 33 over 11 is 3. 40 over 200 becomes 5 and ends up just being 3/5. All right, might as well do 76. 76 is they're giving you a different order in the given part, the B given A instead of A given B. So notice it's B given A, not A given B. So the thing I want to show you about the formula here is the letters match right here. The second letter matches with that one down there. So when you flip the letters, like if it becomes B before A, then an A goes down there on the bottom, but the and stays the same. So some students do write a second formula. It's really not necessary, but hey, it's a final. Maybe it is worth doing. It's still the probability of A and B over the probability of A. Again, these A's match up here. So you're given all the values. B given A is 1/2. Probability of A and B is 7 over 40 over X, like that.
Okay. So then could you just turn 7 over 40 into a decimal?
You could also cross multiply like we did in the previous problem.
Yeah.
Depends on what you like. I mean, some of these work out okay because they're nice numbers that work out. Just be advised, they may not always work out. So this ends up being 14 over 40. And then when you reduce the top and bottom, you get 7 over 20 or 0.35.
Okay.
Now, how do you feel now that we've done some problems here? I mean, is it clear or do you want some more examples or?
Yeah, it's more clear now.
Okay. The formulas are really going to help here. You know, your understanding will come probably later when you maybe take this course again in college, which a lot of students do, depending on their program. All right, number 77. Okay, a litter of kittens consists of 3 gray females, 1 gray male, 2 black females, and 2 black males. You randomly pick one kitten. The kitten is gray or male. Okay. So there's a couple of ways to do this. The maybe do you want us to use formulas or make so there's yet another formula here, which is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So in your problem, this problem, it's gray or male. So you need the probability of gray plus the probability of male minus the probability of gray and male. So it's like saying, figure out all the ones that are gray, all the ones that are male, and subtract out all the ones that are both.
So there's 3 gray females.
Yeah, so there's in gray could be either one. So the gray, you got to count all the grays. So there's 3 gray females, 1 gray male. So there's 4 out of however many total.
The 3, 4, 6, 8.
Yeah,
Oh,
3.
9. 9. No, 8. There's 8.
Yeah, this is 3, 4, like I said, 6. Yeah, 3 out, 4 out of 8 are gray. How many are male?
There are 3.
3 out of 8. And then how many are both? How many gray males are there?
How many gray males?
Yes, that's what the gray and male, that means they're both.
Oh yeah, so 1.
All right, so then you just calculate this, the fact that all the denominators are the same, you're just adding and then subtracting here.
So then it would just it'd be 6 out of 8, which it would be, or should we reduce?
Yeah,
or
you can reduce.
fourths?
Yes. Yes, but you know, kind of just taking a step back. More importantly is that you see that like it's all the grays, meaning like if it's got gray, it could be a male or female, we don't know. These are the males, but they could be gray or otherwise, we don't know. But then it's like there's an overlap. It's like, here's all the grays, here's all the males, but see how you've double counted that overlap? And that's why,
Oh yeah.
you subtracted out.
Okay.
All right, ready to move on to 78?
Yes.
Okay. So this is going to be very similar. I get, as I should have said up here. So this formula up here is good to write each time, the A or B business here, but you really want to replace it with the letters or the words of like what you're doing. So like in this problem here, there's 13 shirts in your closet, 3 blue, 5 green, and 5 red. You randomly select one to wear, probably is blue or green. So this one does work. But we're going to find that there are no shirts that are both blue and green, but it's the probability of blue or green is the probability of blue plus the probability of green minus the probability of blue and green.
So then probability of blue.
So
Wouldn't
yeah,
that be
how many blue are there? There's 3 out of how many?
13?
13. How many blue are there?
5 out of 13.
5 out of 13. And there's none that are both, but I mean maybe in another scenario there will be.
Right. So then it would just be 8 out of 13.
Yes. And you might just say, well, why didn't we just add it up? Well, you can. It's just that you have to, go through the formula each time to see to look for any potential overlap. So if there's no overlaps, you can just add them up like you did here. But in the previous problem, there was this overlap. So you had to subtract out because you double counted.
Yeah.
All right, so why don't you try this one on your own? It's much more, it's much similar to 78 than 77.
So it would be, so probability of A and B,
Right? Maybe go apple or peach
right?
equals the probability of apple. What's the
Plus,
probability of peach minus the probability of A and B?
so then probably Apple would be 5 out of um 12,
Okay. And then peach.
and then it'd be 3 out of 12 or 1/4, but we can
So yeah, good to keep it like that for now. And then
there's 0.
there's 0 that are both.
So then it's just gonna be 8 out of 12, which is 2 out of 3.
Yeah, 8 out of 12 or 2/3. You got it. All right, so why don't you try number 80 on your own before we move on to a new grouping of problems.
So the probability of uh lemon, lime, or orange.
That's right. That's right. It's basically the same process we just went through. You got to find the lemon lime, then the orange, then
I think it's the same answer. I think it's 2 out 2/3.
some of these are so predictable. Yeah. Very good. Okay. So 81 here. We could do a whole lesson on 81 and we're not going to because we don't have that much time. There's you might have heard this brute force method, or someone might refer to like just using brute force. It means you're just going to do it the hard way because it always works. And sometimes that's a good idea, but there is a better way. But for example, here, what this means is 1 minus 4x times 1 minus 4x times 1 minus 4x. Okay, and we do not need to FOIL this. I am going to quickly get us the result of this. I'm sure you know ways to figure out the result of this. What this question is really asking is, can you do this, without finding all the terms? And that's where you have to decide, okay, am I really going to multiply this out? Like this is minus 64x cubed plus 48x squared minus 12x plus 1, because it only wants the fourth term. It only wants the last term here. Okay,
Right.
and there is a recipe, excuse me, there is a recipe to find any of the terms. Okay, and I'd like to show that to you, but I also want to be realistic. Like, do you think you will actually want to remember this? But because otherwise you do have to multiply it out, and it's fine when it's 3, and maybe a 4 is fine, but at some point you're like, boy, this is not going to be all that easy. So I'd like to show it to you. You can decide afterwards, hey, I don't want to do that, but is that okay?
Yeah.
Okay. So there's the first thing, there's this thing called Pascal's triangle. Have you seen this before?
Oh, yes, I have.
Okay. And you need it for this problem. Now it starts at row 0, 1, 2, 3, like that. And so notice that you have 4 terms here because it's power of 3. There's always one more term than exponent here. So we need these coefficients. We're going to get to how to use those in a moment, but this is how you start out. You have to start out with this. Second thing is to remember that it's really like, and I use this notation, A is 1 and B is minus 4x. Okay. And so your terms look like this. You have to take your A to the power of 3, the other term to the power of 3 minus 3. You're going to see a pattern here. And then there's a coefficient. Now this one's actually backwards. I should probably note that as well. This really isn't the right one to be doing this with, but that's okay. Yeah, that's okay. The next thing is it's 1 to the power of 2 minus 4x to the power of 1. Okay. So this 3 minus 3 is really 0. And what you're noticing is that the sum of the exponents is always this 3 here. And there's also this leading number, which we'll get to. 1 to the power of 1 minus 4x to the power of 2. Again, see how the 1 and the 2 add up to 3?
Right.
And then you've got 1 to the 0 minus 4x to the power of 3. Another thing you notice here is the 3, 2, 1, 0, they're going down, 0, 1, 2, 3, they're going up. And then you're like, well, what's going to go in this front position? Pascal's triangle. So these try to move these numbers over. They're kind of unclear. You're going to use these coefficients 1, 3, 3, 1. Like this. But you're not done. You actually have to do the operations here, like 1 to the power of 3 minus 4x to the power of 0. So 1 to the power of 3 is 1, minus 4x to the power of 0 is 1. 1 times 1 is 1 times 1 is 1. For the second one, 1 squared is 1 times minus 4x becomes minus 12x when you multiply by 3. This is 16x squared times 3. That's 48x squared. And then this last one here is minus 64x cubed times 1, minus 64x cubed times 1. So notice these are exactly the same terms as I wrote down up here. So it can be done. Let's look at another problem. Is that okay?
Yes.
Okay. So 82 here. You identify you identify the exponent 3. So it's always the first thing inside parentheses to power of 3. The plus or the minus goes with the second one. So it's positive y to the power of 0, because these two numbers need to add up to 3. Then you go down, you say, okay, it's x squared, y to the power of 1. Some numbers in front. We'll get to that. And then you keep going down. So it's x to the power of 1, y to the power of 2. Notice that one's getting bigger. Some sort of number in front. And then x to the power of 0, y to the power of 3. And then some sort of number in front. So 1, 3, 3, 1. That comes from Pascal's triangle. There's another way to do it, but the Pascal's triangle is the most straightforward. Or maybe I didn't even explain how to do Pascal's triangle, but you then evaluate each of these. So it's 1x cubed, or just x cubed. X squared y times 3, so 3x squared y. 3xy squared. And then x cubed. I'm sorry, y cubed. So this one has nice symmetry. So when it asks for the second term, got to be careful here. It's in kind of descending order. So the second term, so draw, here we go. Second term is this one here.
Okay.
Maybe seeing one more will be sufficient to kind of understand. So Pascal's triangle, let's just briefly go over that. You always start with a 1. one's down the outside. You add up these two ones and put the result in the middle. One's on the outside. So then you add these two numbers, 1 and 2, you get 3. 2 and 1, you get 3. 1's still on the outside. So notice like the number of entries goes up by 1 each time. 3 plus 3 is 6. 1 plus 3 is 4. 3 plus 1 is 4. Yes, there is a symmetry that you will see. Now you might be wondering why we went to this one. It's because it's a power of 4. 4 means you go up 1 more. Lots of rules in math, doesn't really stop here. So we're going to use these coefficients. X is kind of your first thing, positive 3y is your second, and you have to do that exponent balancing thing again. So it looks like this: x to the power of 4, 3y to the power of 0. And then the number that goes in front is this 1.
Yeah.
You might well ask, why isn't this other one? Well, it could be because they actually, there's symmetry, so you don't ever have to worry about anything weird happening, which is nice. Next one is x cubed, 3y to the power of 1. Okay, and that's a 4. And then x squared, 3y to the power of 2, that's a 6. And then x to the power of 1, 3y to the power of 3, that's a 4. X to the power of 0, 3y to the power of 4, and that's a 1. Now it just asks for the second term, so we just need to do this one. So we could have stopped there, like we didn't have to keep going, but.
Right.
So this ends up being 4x cubed times 3y. And so you do multiply, this becomes 12x cubed y. So if you really want one, I could give you one to try, or you can say, you know what, I think I can maybe figure it out in the test, totally up to you.
I think maybe do one more like this because I don't know, Pascal's triangle is a little confusing sometimes to me.
Sure. So I don't want to make it too bad, but I should throw in a negative at some point. Let's go 2x minus y to the power of 3. And here is Pascal's triangle. This is all you need for this one.
So
The 2x, what is the first exponent that you use for 2x?
would it be 1?
You always start with this exponent.
Oh,
Okay, and then it's minus y. The exponent that goes above the next one, the sum has to get you back to 3. So 0. The next one is 2x to what power?
is it? Do you go down and just go to
You go
2?
you go down and then the other one goes up. You
Right.
still have
Oh,
to add up
okay.
to,
I remember now. Yeah.
still have to add it up. And then the next one here is 2x to what power?
1.
All right, and minus y to the power of, what would that be?
2.
Okay. And then 2x to the power of 0. minus y to the power of what goes above the minus y
That's
here,
3.
3. And then the coefficients come from here. There's 4 that matches up here. 1, 3, 3, 1. All right, so why don't you calculate the I don't know, let's have you calculate this one here, please.
Mm. Is it 0?
So you're 2x to the power of 2. Start with that. So you're squaring both the 2 and the x. So that becomes 4x squared. And you still
Oh,
have
I
the
see.
you still have the 3 out in front. Still have the 3 out in front, and then this minus y. So the negative goes with it. Just put it down here. Negative 12x squared y.
Okay. I think I plugged it into my calculator and I pressed the wrong button and it hit 0. I was like, that doesn't seem like it would be 0.
Yeah, and happy you can use the calculator. Some calculators will even do this for you, but it's not difficult, but there is a pattern. Like, and if you don't follow the pattern, you won't get the right answer. But it's not like any one of these steps isn't hard. It's not that hard to add these numbers together. It's not that hard to put the exponents in descending and then ascending order. It's just getting it all together. And that's why I said, like, you worst case scenarios, you can just multiply it out, foiling, multiplying, foiling. You know, it's tiresome, but it can be done.
Right?
Do you want to do us to do another one, or do you want us to move on to some other problems?
Maybe we can do 86 or 87, like one of the
Sure. Yeah, that's
to
a good
like
idea.
finish off. Yeah.
Sure. So this is the more generally, this is the solve the triangle problem where they want you to find everything in the triangle. Like, and I know it doesn't say to I know it says just to find x, but just assume for a moment that you wanted to find everything in the triangle. Okay. Angle B is 50. What's the measure of angle C?
90 degrees.
90 degrees. And then A is 40. How did I come up with 40 for A?
Add to 180 and subtract.
That's right. And then there's little a, little b, and little c. Little c is across from big C, little a is across from big A, and little b is across from big B. Right. And then the next thing is to find the side. So we know that like A is 11. I'm sorry. We know that A is 11. They want C, so let's find C first. So this is where you're using your sine, cosine, and tangent. So you mentioned getting like a reference sheet on your test, or writing one down. Maybe
Yes.
this would be good to have on there. You know, some of these trig formulas. So relative to this angle, 50 degrees, what is 11 and what is x or c? Like, and your answers are opposite, adjacent, hypotenuse. Because by figuring that out, you can figure out which one of these to use.
So, I always confuse this. Okay, so
So
okay, so
the
C is the
hypotenuse,
hypotenuse.
yeah, the longest, the one across from the 90 is always the hypotenuse.
And
The
then
leg that's furthest from you is the opposite. So B is opposite in this case.
So then we would use sine.
Well, if we were interested in finding B, we want to find C and we have the adjacent, which is A.
Oh, so then it would be cosine.
Yes, yes. You could write the cosine of 50 equals 11 over like that. C is really X. So just like before, to solve for X, because it's on the bottom, you can multiply both sides by or diagonally multiply. So you get X cosine 50 equals 1 times 11. So X is 11 over cosine 50, like that.
So then you
So
just
go ahead.
plug that in your.
Yep. And let's just make sure we get the same result here. Let me know what you've got.
I got 17.1.
Good. And it's C, it's the hypotenuse. It should be bigger than A. So we'll go 17.1 there. So to find the other side, B, lots of options when you have the third side. You can either use the trig or you can use the Pythagorean theorem. Either way will work out just fine. All right, so let's quickly look at 87 and actually find the value for 87. All right, so again, just you kind of have to say, okay, I'm here at the 40 degrees. I'm right there. What is X and what is 3 relative to that? And again, you're trying to decide, well, I'm using sine, cosine, or tangent. I snipped them all in, but let me just snip in sine, cosine, and tangent. You know, which one works here?
So we have hypotenuse
Yes.
and we have the opposite.
Yes. So it's
So
the
we need to find
sine.
adjacent.
No, you're trying to find the opposite. X. You're trying to find X.
Oh, because opposite from the angle. Okay, so we have
Yes.
adjacent and, or no, we don't even.
You do not have the adjacent. You have the hypotenuse, and you're looking for the opposite. But you have that. You're trying to figure out which 2 of the 3 you have. That's how this choice is made. Because you have the hypotenuse and you're trying to find the opposite. That's good. That's
So
how
then
you.
use sine.
Yes. Okay, and this is the better case when the variable's in the numerator.
And then you just cross multiply.
Yeah, this case, there's
So
nothing over here
divide.
on the bottom, so you can just 3 sine 40 equals X.
So 1.93.
Sounds right. Let me just double check here. 3 sine 40. I got a different number. You're just multiplying 3 and sine 40.
Let me see. Let me put it in again.
Maybe I didn't hear the answer you gave correctly. It's been a long day.
Yeah, I got 1.93.
Yes. Okay. I must not have heard it.
Oh,
Neither do
okay.
I. Great. All right. Good stuff there. So we're all done for today.